Okie dokie. So something new today, not just another part from the mini train. So right now, if you did the first document for the first two pegs, this is probably what your folder looks like. If, for those of you in class right now, if you haven't done either of the first two pegs, hang out for a second so you don't have to redo it. If you have done both of the pegs, the easiest way to move forward is to redo one of them. I will show you how. Okay, so before, the plan was to, inside of the mini train folder, you would have all 10 of your part files. The problem is that the way assemblies are done, assemblies are tabs within the document. And the easiest way to do an assembly is to have all of the parts for it in the same document. So here we would make this, and you should rename this one Hitch Pig. Okay, and then make a new create part studio. And in this one, this is where you would make linkage peg. Okay, so all the part files will be tabs in the same document, and then the assembly will be the last tab in this document. It is sort of possible to, when you get to assembling, to insert from other documents, but it is a lot more work, and there's issues with versions and that sort of thing. It's actually going to be easier to just make all of your drawings in the same document, which means go to Hitch Peg, open up your Hitch Peg, and this is where you will add the second tab so that all the tabs are in the same document. Okay, so that means you would rename Hitch Peg here, rename, this would be mini train. Okay, because it's going to have all of the part files for the mini train will be in the same document. Okay, it's fine if it's in a folder called mini train and there is your document called mini train. And just so you don't have to go back, I will remake linkage peg in here. And then you'll see making sure that all of your, I'm gonna have to repeat this 1,000 times because it's important, making sure all of your documents, all your different part files are tabs in the same document and not different part files in that folder. Okay, it will save you a ton of work to do that. Okay, so let's keep going. So inside of my mini train document where I have the different tabs, I am going to make the linkage peg again, just real fast. I don't need to explain it the way I have in the past, just fly through it. And let's go like this. And something like that, a little smaller. And let's go ahead and we'll do a sketch on the front. Look at it straight on, turn off our origin planes. Let's go ahead and go full screen. Line vertically, make sure it snaps to vertical. Dimension that to the height, which I believe is 0.325. And I can zoom in a little bit. And so that's 0.325 is our vertical height. We need this bottom horizontal line, which is going to be half of this, 0.0625 divided by 2. and dimension 0.0625/2. It'll do the math for you, which is 0.03125, I think. Whatever it rounds to is fine. And then we need a line going up the outside. Make sure that snaps to vertical. And 0.25. And we need the horizontal line, which this is the one they don't give you the dimension for, but it's probably, can't remember what I said before. We're just going to eyeball it for that one. And that leaves just the arc. And this arc that's going to connect this point, even though they didn't tell us the length of that line, this arc has a radius of 0.1562. So we can go ahead and do our 3-point arc, which almost all the arcs are going to be 3-point arcs. And we will dimension this 0.1562. And done with dimensions. Does this still move? Yeah. Okay, so as long as the length of this line is short enough that the arc doesn't go up before it goes down, you're fine. Because if it goes up before it goes down, when you finish the sketch, do the revolve, choose our shape, then choose the axis. If it goes up before it goes down, it's going to leave that dimple in the middle, which you can kind of see from, oh no, do I get rid of it? Please tell me there's a redo. Yeah. And let's edit the sketch. So let's see if we can, how about I just come up with a good number? I bet it's a nice even number. About 0.15. Yeah, if you just make the distance between the end point and our center line 0.15, you'll be fine. And we'll finish sketch and revolve. Oh, you know what? It's not actually fine. You can see, even though it's very slight, you can see these aliasing, which is what the way computers make curved lines. They have to make sort of jagged lines, which I don't know if you'll be able to see on your screen, but that shows you that it very slightly goes up. Let's see if we can find a better dimension. I click edit. How about 0.125? That's a nice even number. Yeah, that looks a little better. And we'll revolve, look at it from a corner. Revolve, first click is somewhere on the shape, and then we have to tell it which axis. So we'll click on this red box and then click on our vertical center line and hit select. Okay, so at this point you should have hitch peg, linkage peg, and an empty assembly, which if I was doing this on a completely original part, or assembly, I would make one part, whatever the base or body or frame or something like that was first, and then put that right in the assembly and keep making a part and keep adding assembly. But for this, because we're introducing these different concepts one at a time, we will do all the parts and then the assembly. Okay, so there are the first two pegs, all in the same document, all as different tabs. And so we need to make another part file. So we're going to go to the plus sign here, and we're going to go to create part studio, which will give us another tab. And it's already active. Let's right click, rename. Let's call this one axle peg. Axle peg. Okay. And so let's look for axle peg. Axle peg is a little different. There's a couple ways to do this. One is, I'll show you both ways because it'll be important later on. One is to sort of like infer the sketch that we would do a revolve. Like, even though it's not presented as our revolve profile with a center axis, it's still radially symmetrical. It still can be made with a revolve. You just need to figure out what those dimensions are. And we would still make it with a tall vertical line, a horizontal line, half of the distance, half of the diameter of the threaded part, a vertical line, the length of the threaded part, and then work our way around with tiny lines until we get to the arc and revolve it. That's the first way we're going to make it. And yeah, so let's figure it out. Just like before, our first vertical line is going to be our center axis. And we know, let's look at this. Okay, so let's go ahead and sketch on the face called front. And we can turn off all of the origin planes. I do want to keep that point so it's the center of everything. And look at it straight on. Okay, so we know that we're going to start with a vertical line as our center axis. And how long is that line? Well, the length of this line is the total height of the peg at its tallest point. And so first thing I do is sort of break down what these numbers mean, and I'll just explain them. Okay, so 1/4 in this context refers to the diameter of the threaded part. 20 UNC has to do with the pitch, the type of thread. It's a standard, like one of the standard types of thread, spirally screw part of the bolt. By 1 means 1 inch. The shaft part of this is 1 inch, and a 1/4 inch offset is 1/4 of this inch is not threaded. So the main takeaway at this point is that from the bottom of this sort of ledge to the bottom of everything is 1 inch, which we know our shape is going to look something like this. This is what's 1 inch. The distance from here, the distance from here to here is 1 inch. So the total height is going to be that 1 inch plus whatever the head part is. And the head is 0.125. You can follow this extension line. Hold on a second. Okay, so the height of this vertical line is that 1 inch plus the height of the head, which is 1.125. Okay, then we have, just like before, our horizontal line here and a vertical line here. I'm just going to make them both and then dimension them each. We know that we want the diameter of the threaded part to be 0.25, that 1/4 20 UNC thing. And so that means this needs to be half of that, which you can just do 0.5/2, or 0.125 is how much that is. And then this outside part is, like I said before, 1 inch. And we'll do right click, escape dimension, and we can also, so normally when you have a tool, if you click a different tool, it will turn it off, but you can also do right click, escape, or you can do the escape key on your keyboard. All right, so this height over here is 1 inch, and normally I would leave the dimension, the length line part, over on this side just to sort of keep it out of the way, but just like the other pegs, it's about to get busy in this area and crowded. So let's just keep it over there. Okay, so the remaining dimensions, we have the total height of 1 1/4. We go out to do the revolve width, the height of the outside part. Then in order to make this shape, we are going to go out just like before, except instead of going out 1 and doing an arc like the other ones, there's actually a tiny vertical part here. And the way you'd make that vertical part is with a short vertical line. And then there's a flat part at the top, and the way you make that is with a horizontal line. That way, when it revolves, it leaves this smooth edge on the outside, and it leaves the flat part on the top. And then it's just connected with an arc between those 2 points. This hexagonal hole we will do last, or we'll do this part last also. Actually, I don't know if it has threads. We'll work on it. Okay, so first thing is this horizontal line, which is going to be dimension from the center of everything to the end of it. So we just need a horizontal line going that way. And the dimension tool, again, because the dimension we have is at the widest point, it's 0.422 diameter at this widest point, and that's all the way across. So that means we need half of that from the center of everything to the point on the edge. And why are we doing this? Dimension from there to there. And this needs to be 0.422/2 or 0.211. Okay, so that's just like we've had before, except now we have a short vertical line there and a short horizontal line here. And the lengths of those, we know this vertical line is 0.031, and the horizontal line from the center out is part of a revolve, so that dimension is cut in half. And the design diameter is 0.25 on this flat top, so it needs to be half of that because it's a horizontal dimension. And so this one is 0.031. And this one is 0.25/2 or 0.125. I wonder if, does it leave it in there as 0.25? Oh, it does actually leave it in there. That's good. Keeps that information. And the last portion is just the arc, which in our case is it's dimensioned as spherical radius because when it's done, it's part of a sphere, which is a radius of 0.236, which is the radius of the arc we need to make. So let's get our 3-point arc and dimension from there, or first click there, second click there. And again, you need to make sure that it is sort of close in the right direction. If you go out past halfway, and even if you put in the correct dimension, 0.236. Okay, so that is the correct dimension. But because we started the arc, or I started the arc incorrectly, it jumped to that conclusion. So is there easier? Yeah, that's fine. Okay, so we're just going to do a regular arc, 3-point arc, first click, second click, and third click is just how barely arcy you want. And arcy is not a real word. It is now. Okay, and we'll dimension this to 0.236, which is the same I put in before. Why is it not working? Oh, it did. Is the internet just garbage right now? I think it might be. Okay, so there's our profile. We're going to finish the sketch, look at it from a corner, do a revolve. First click is in the center of everything. Then we need to tell it we're selecting the axis of revolution and choose it there and hit OK. Okay, the two other features, let's go ahead and get rid of the origin point. We don't need it anymore. The two other features are the hexagonal hole in the top, which is just a basic hexagon. And honestly, didn't even check. I'm not sure if they have the polygon tool. They probably do. If they don't, we won't worry about it. But either way, it's a hexagon that is 5 30-seconds across flats, meaning the distance from one side of the hexagon to the other is 5 30-seconds. And it says 0.111 deep. That's how far that shape is extruded. So let's see if they have a polygon tool. Let's sketch on the surface here. And we do have a polygon. So inscribed polygon, it doesn't matter which one as long as you don't snap it to anything. But you can see, I can't really zoom in, see where the dots are. Inscribed meaning the second click is on a flat. Circumscribed means the second click is on a point. And like I said, for us, it doesn't matter. Let's just get the first one. And wait a second, we need to use that edge there. So now we can snap to the center point. Let's get polygon, first click in the center, second click really anywhere. Oh, gotta be a better way to do this. How do you set? How did I change the number of polygons or the number of sides? Okay, so this might be difficult with a touchpad, but let's see if I can do it without that. First click is in the center, second click outside. And at this point, if you move up or towards the inside, so this number here in the middle is how many sides I want. And depending on where your mouse is, like on the screen, like closer to the center is a lower number, farther out is a higher number. We want 6. So wherever you can make it 6, that's what you want. And right click done with escape polygon. Let's see if you can change this afterwards. What happens if we, okay, so you can double click on it. That's fine. So you could, in theory, change the number of sides. That's fine. So we want 6. And then we want to dimension across flats, meaning the distance from one side to the other side. And I misclicked there. First click, second click, and let's just get it out of the way. We want 5/32, which is a fraction of 0.56. We'll finish the sketch. And you can see there what our polygon looks like. We're going to do extrude, choose our polygon, switch it to remove, and the depth is 0.111. Okay, and so let's see what if we can do the chamfer. Okay, so the chamfer, I think we've done before. We definitely did a fillet, but the chamfer is this knocked off edge at the bottom, which is just going to sort of slant it in. And 45 degrees means it's, so if this is the shape of our resolve, 45 degrees is just the angle of this, which, and then the dimension 0.03 is how far in from the edge that slant goes. So you can see on the little pictograph here, this is the chamfer. And first thing we need to do is choose the edge we want to chamfer, which is the edge of this. And the dimension we want, it's not even showing a preview because that would be too big, 0.03. Enter, and equal distance is the same thing as 45 degrees. So there's a chamfer, super easy. And does this have threads? What's another word for that? Screw? Helix? I'm not doing a helix. It's actually like a surface thing. It's not a real thing. All right, so make a section view, make transparent, show curvature. Okay, but we'll just leave it there at that point for axle peg. So at this point, you should have 3 tabs: hitch peg, linkage peg, and an axle peg, and the assembly should be empty. All right, so let's see if so I don't want to do another long one on the same recording. Let's knock out a couple easy ones. Okay, so hitch magnet, super easy. It'll take about 1 second in total. And yeah, let's do hitch magnet. And so this you should probably be able to do on your own. We've done much harder things, but just because, you know, it's nice to have a full set. You need, okay, so here's a big hint. Every one of the dimensions that is on a technical drawing is needed to make that part. And that's actually like a key concept for doing technical drawings. Okay, hold on a second, you might learn something. A key concept for doing technical drawings is you need to put every dimension on there that is needed to make that part, but you don't want to put any extra, because that makes things crowded on super complex things. So it's about getting the correct number of dimensions and the right dimensions. Okay, so you can see the diameter symbol. So you know that this 0.45 is pointing to this edge, which is the outside, and this diameter 0.25 is pointing to the inside. And because of the sort of dotted lines, you know it's hidden. So we're going to make one circle that's 0.45, extrude it the height to make a disc, cylinder, short cylinder, and then we're going to put a sketch on top and do a cut extrude. You could put both of the sketches on. In fact, yeah, let's go ahead and do that. Let's put both of the circles on the same sketch to make the donut, and then extrude in a single extrusion. I don't think anything's better than the other, but so we need a new create part studio, and now we have this tab. Let's right click and rename. This is called Hitch Magnet. And let's go ahead and do a sketch. Why not the front plane? That's fine. Let's go ahead and turn off the origin planes, look at it straight on, get our center point circle, and we're going to make 2 circles that are actually pretty small. 0.45 is one of them, and we can zoom in, and then another circle inside of that, which is 0.25. And I missed. How did that happen? Let's see, can I drag this? How did I not? Is the snap hard? Soft snap. No, that's fine. Okay, just make sure it's centered, otherwise it won't be correct. I don't, yeah. And so now we have our 2-dimensional sketch. We'll finish the sketch and we'll go to extrude, and we only want to select the outer part. There we go. And the distance to extrude is 0.25. And you can see that's what we have here. So we'll finish sketch. And at this point, you should have 4 part files or 4 part studios that look like that. Okay, there you go.